What we'll be going over today is division of powers with the same base. Remember, the base is the large number right here, okay, and the exponent is the number that is smaller and above and to the right of the base. So this is the exponent, this is the base right here. And when we say they have the same base, see, this is a base of 5, this is a base of 5, so they have the same base. And whenever they have the same base, there are special things that you're able to do with them. So let's try this. 5 to the 6th divided by 5 to the 3rd. Now if we were to write this out, that means 5 multiplied by itself 6 times. See, 1, 2, 3, 4, 5, 6. 5 multiplied by 5 6 times. Divided by 5 multiplied by itself 3 times. Now remember, when you are dividing and you've got numbers in the numerator and numbers in the denominator that have common factors, you can cancel out some of those factors. So 5 is divisible by 5 one time, so we put a 1 here, and this 5 is divisible by 5 one time. Same here, 5 one time and 5 one time. And finally there's a 5 here that goes into 5 one time, and 5 will go into this one time. There's nothing left on the bottom, so there's no more simplification that we can do. So what we have left are these 1 times 1, which is 1, times these 3 right here, which will give us 5 times 5 times 5 over 1 times 1 times 1, which is 1. And when you have 5 multiplied by itself 3 times, what you have is 5 to the 3rd. Now, how did we go from 5 to the 6th over 5 to the 3rd to 3? If you remember, well, let's do this first. Multiplication. What is the opposite of multiplication? That's right, division. And what's the opposite of addition? That's correct, subtraction. So remember when we did multiplication of bases with the same power? What did we do with the exponents? Correct, we added them. Okay, so when we multiplied with the same base, x powers with the same base, we added the exponents. So if we had 5 to the 3rd times 5 to the 6th, we added the exponents and we got 5 to the 9th. Well, since division is the opposite of multiplication, then it makes sense that if we added with multiplication, we are going to subtract with division of powers with the same base. So if you have 5 to the 6th over 5 to the 3rd, that will equal 5 to the 6th minus 3, which will equal 5 to the 3rd, which is what we got when we did it on the previous page. So let's try this a few times and see how this comes out. Oh my, look at all these problems. Okay, we've got x to the 4th, y to the 3rd, over x squared, y squared. Remember, this only works when they have the same base. So when you're working with this one, you can only combine the x to the 4th with the x to the square, and then you can combine the y to the third with the y to the second. So x to the fourth over x to the squared. Remember, we're subtracting exponents. So that's going to be x to the 4 minus 2 and y to the 3 minus 2. 4 minus 2 gives us 2, so we'll have x squared. And 3 minus 2 gives us 1. But in algebra, remember, if there's a 1, it is understood and you don't have to put it. So we would write x squared y, leaving the 1 exponent off. Okay, this one. We've got 3x to the negative 4 over 6x squared. And if you recall when we did multiplication of powers with the same exponent, when there were coefficients involved, we worked coefficient with coefficient and powers with powers. So we've got 3 over 6. 3 over 6 is 1/2. Okay? And then we've got x to the negative 4 and x squared. So that means we're going to go negative 4 minus 2. Okay, so we've got x to the negative 4 minus 2. Then we simplify this and we'll get 1/2 times x negative 4 minus 2 gives us negative 6. That gives us x to the negative 6 because you go numerator times numerator. Remember, this is x to the negative 6 over 1 like that. So when we multiply this out, we're going to go numerator times numerator and denominator times denominator. So that gives us x to the negative 6 over 2. And since we write, unless you're instructed otherwise, you write with positive exponents. What do we do with a negative exponent? We move negative exponents to the other side of the divisor line and change the sign. So that means that this is now going to be 1 over 2x to the 6th. Now let's try a different approach to the same problem. Okay? 3x to the negative 4 over 6x squared. 3 divided by 6 is 1/2. We've already established that in the previous one up here. Now, since we want to write it with a positive exponent, what we do is we take the exponent which is larger, which is the 2 here, and we know that our answer is going to be maintained in that side of the divisor line. So the 2 is the larger. So instead of going negative 4 minus 2 like we did in the previous one, we're going to go 2 minus a minus 4. So the previous one we went x to the negative 4 minus 2. This time, since we're dragging it, we're going to bring it down to the bottom. So we're going to go x to the 2 minus a minus 4. Okay? So that gives us 1 over 2, which is what we got up here. And then we'll go 2 minus a minus 4. Remember that minus minus becomes a plus, so we're going to have 2 plus 4, which is 6. So that gives us 1 over 2x to the 6th. So it saves us a step if we do it that way. Okay? Alright, now let's try this one. Where is the larger exponent? For the c's, ones with the base of c, the larger exponent is the 3 here. Okay? For the d's, the larger exponent, right, negative 1 is larger than negative 3, because with negative numbers, the closer it is to 0, the larger the number is. So that means that in both cases, the larger exponent is on the bottom. So that means when we subtract, we're going to bring this one down and this one down and do our subtraction. So that It's going to go 3 minus 2 gives us 1, so we're going to have a C on the bottom, and negative 1 minus a minus 3 gives us a 2, so it's 1 over CD squared. Okay, now this one, we're raising a fraction to a power. Now, this is just like the distributive property, okay? With the distributive property, if you've got 2 times x plus 4, that means that you go 2 times x, and you get 2x, and you go 2 times 4, which gives you 8. Okay, now, over here, that means that this exponent goes with the 3, it goes with the x to the 4, it goes with the 15, it goes with the x, and it goes with the y squared. You've got to put it with everything, okay? So, 3 squared, okay, 3 squared, and then we've also got x to the 4th squared. We'll have 15 squared. We'll have x to the 1st squared, and we'll have y squared squared. Okay, now that gives us 9. Okay, 3 squared is 9. And then we've got x to the 8th, because 4 times 2 is 8. Then down here, 15 squared is 15 times 15, which is 225. X to the 1 times 2 gives us x squared. And y squared squared, 2 times 2 is 4. So that gives us 9x to the 8th over 225 x squared y to the 4th. So that gives us, sorry I hit that ahead of time, but 9 and 225 are both divisible by what? The first thing you always check is the larger number divisible by the smaller number. Does 9 go into 225? Remember our divisibility rules? 5 and 2 make 7, and 2 makes 9. If the sum of the digits of a number are divisible by 9, then the whole number is divisible by 9. So when you add 225, the digits up, 5 plus 2 plus 2, you get 9. 9 obviously is divisible by 9. So that means that 225 is divisible by 9. 9 goes into 9 one time, so we'd have a 1 here. 9 goes into 225 25 times. X to the 8th over x squared gives us 8 minus 2, which is 6, and the 8 is the larger, so it's going to be on top. And y to the 4th, there is no other y on the top, so it stays on the bottom and becomes y to the 4th. Our answer is x to the 6th over 25 y to the 4th.